Okay, welcome back. I hope you all enjoyed the lunch and are re-energized for our next session. May I please ask the speakers and the chair for the next session to come on stage. We will talk about the transparency of generative AI, and allow me to welcome, first of all, Dr. Anton Zimmermann, who will chair the session. Dr. Zimmermann has completed legal studies at Heidelberg University, earning a first state exam in 2016, a PhD in private law in 2020, and has completed the second state exam in 2021. Following his studies in economics at the University of Hagen, Dr. Zimmermann has been a postdoctoral researcher since 2021. Starting in summer this year, Dr. Zimmermann has been leading a German Research Foundation-funded junior research group at Heidelberg University's Institute for Comparative Law, Conflict of Laws, and International Business Law. The focus of the group lies on private law, law and technology, and the interplay of public and private international law as a governance tool. Allow me also to welcome Professor Andreas Dengel, who is a Japan hand with a long history in Japan here and a long-time collaborator of us. Professor Dengel is professor at the Department of Computer Science at RPTU, the Technical University Kaiserslautern Landau, and managing director of the German Center for Research, the German Research Center for Artificial Intelligence, DFKI, in Kaiserslautern. The center also has an office in Osaka at Osaka Metropolitan University. Since 2009, Professor Dengel has been a professor at the department of this said university, Osaka Metropolitan University. He has received many awards for his work and scientific endeavors, including being selected by a jury on behalf of the Federal Ministry of Education and Research in Germany, the BMBF. 2019 as one of the most influential scientists in 50 years of AI history in Germany for his research in the field of document analysis. He's recipient of the Order of Merit of the State of Rhineland-Palatinate and has been honored in 2021 by His Majesty Emperor Naruhito with the oldest Japanese order, the Order of the Rising Sun, on the necklace with golden rays. Allow me also to welcome Professor Florence Dalchet-Buc. Professor Dalchet-Buc is professor at Telecom Paris in the department Image, Data and Signal, and she has led the department for more than 2 years. She has served as program co-chair of NUR IPS. I'm not quite sure. Okay, NURPS. Okay, thank you. 2019, and was scientific director of DG COSME, the Paris-Saclay Excellence Center in Computer Sciences, from 2017 to 2019. She's held the Telecom Paris chair on data science and AI for industry since between 2018 and 2023, and is a member of the Alice board. Her research spans various areas of machine learning, including structured output prediction and frugal and trustworthy AI. Her leitmotif, so to say, is to develop mathematically grounded AI to solve key challenges in biochemistry and energy and industry. And Professor Katagiri, you had the pleasure of meeting before, so I skipped the introduction here as you already know him. So Mr. Zimmermann, if I can turn to you. Thank you.
Thank you very much. So first of all, I'd also like to thank the organizers and the speakers, and of course all of you for taking the time to come here and listen to the keynotes and also to the discussion afterwards. I think that the subject of transparency does not really require any further justification at a conference on artificial intelligence, at least these days. I think we've all seen the memes of funny hallucinations of artificial intelligence, and so therefore I think it's quite clear that the black box of AI needs to be pried open as far as we can do that, at least. And so I'm really looking forward to all of the presentations, and so without further ado, Andreas Dengel, I'd like to give you the stage, and I'm looking forward to your presentation.
So thank you, Anton, and thank you, Axel, for the kind introduction. I'm glad to see you all here. So I'm not talking about a trailer of the well-known movie. It's about transparency in respect of interpretability and also explainability of AI systems. And this also includes, of course, generative AI. So you all know such examples which came out through the press where people are eager to see what AI does, and so AI sometimes fails based on the data bias or based on the complexity of the system, and this holds for many deep learning systems specifically which are built on training, because we as humans can't oversee all the cases of the training, maybe also the bias of the data as well. And this also not only holds for deep learning in general, but also specifically for foundation models. And we have jailbreak or other adversarial systems which are trying to fool systems through penetrations on the character level or word level or sentence level. And there are dozens of adversarial tech frameworks which are built to show the deficits of these networks. So basically, we also learned that we have these networks which are quite exceptional good in many cases, since they are acting on multiple data, not only on images or text, but also on time series. And usually they are trained on cases in order to find anomalies or correlations. But one of the major deficits, as you know, we already talked about, is there is a black box. So transparency is vital in many domains, whereas description regarding the decision is equally important to the decision itself. Yeah. So we need also some more insights into the systems. And since we know that the complexity of the systems is still growing, this demand is higher, and also the trade-off between the system's autonomy and the transparency itself. So what could we do here? So there are many questions regarding how to get insights into the system's behavior. And this is on one hand side through interpretability, which is going to observe how systems behave. It's the observation of the insights of cause and effects of the systems without necessarily knowing why something happens. On the other side, there's explainability, which is concerned to the ability to explain the inner function in a mostly human-like way, so maybe via text. So these are general attempts to talk about these two dimensions. We also published a paper, the XAI handbook, so where we also try to investigate the many dimensions of explainability and interpretability in here. So if we look at the black box, it's quite important to have more insights into the decision making, namely also which data is responsible for the decision making, to see the data dimensions, and also to understand more about the decision processes, so which filters behave in what manner in a certain situation. The same holds for the traceability and reliability, and also hopefully expressive models to get insights and let the system justify the decision making. So in general, if we look for AI, we have maybe two dimensions to consider. On one hand side, the degree of explainability, and on the other side, we have this quality of the results. And as you know, there's not only generative aspects of AI, but there are many. And so there are also symbolic approaches like classification rules or regression technologies, as well as decision trees. And we also have graphical models, and moreover, then the statistical methods, including the deep learning, where we have this discrepancy in the quality and also in the explainability. So what should we do? What solution do we have in order to overcome the weaknesses of these generative approaches and also the deep learning approaches? Of course, there are new techniques now with causal reasoning, which are combined with the neural networks, which allow us maybe to ask and translate a prompt into a SQL statement or a Spark query, and do this in a stepwise manner in order to get more valid, more factual results instead of hallucinations. But you should also see that there are many domains where we don't have such causal aspects given. For example, in medicine, where we have many empirical studies which are based on what medical doctors and specialists do. So in this way, I today want to focus on an example from medicine, namely of diagnosis, and to give you an insights what's possible to justify the decision-making of an AI system, specifically also because this medical area is dominated by not huge amounts of data, but rather with special data which is stored at typical places in hospitals or at research centers. Not all of the scientists have access to the huge data sets, which costs a lot of money. So to overcome this problem, we try to follow a specific approach. But anyway, I focus on a well-studied domain, namely skin diseases, where we have lots of different types of lesions with different degrees of dangerous, which are somehow malignant, or we also have on other side benigns, so nevus data, which are not that dangerous, and there is a kind of categorization possible in this domain, and there are many papers on this domain. However, if you look to this domain, it's characterized by some aspects. On one hand side, it's very common all over the world, so many people have such lesions with a different degree of death rates, but in general it's a high impact disease, so it's worth to investigate in more detail. So if you look at the various pictures of such lesions, you can see lots of different characteristics which are given, for example, in the pigmentation of these different lesions. You also see that there are radial extensions, or you have a network boundary outside, you have different colors which are mixed, and so on. So different visual characteristics which are also used by the specialists. However, as I already mentioned, it's very difficult even for the experts to do diagnosis. So in many cases they take probes and then do a further examination. And another deficit is that there is no gold standard given to allow us to really see which technique would be best in a certain way. So if we go 7 years back, there were already colleagues of Stanford University who published a paper in Nature, and they showed that AI systems could be of equal quality compared to human experts. However, here again, we have this black box, Nature, and the intention is to get a deeper insights into the behavior of the deep neural networks. So coming back to what I mentioned before about these visual concepts and the experts, so in many cases, experts also use a certain way of analyzing the lesions separately concerning to this or related to these visual concepts here, so that they have a way, for example, ABCDE method is a very common way, where they check how present some pigment structures are, or you can see irregular streaks and so on. So they have the option to use such slider systems, and at the end to have something like a score in order to rate whether this lesion is dangerous or not. So based on this kind of introduction I gave you, we followed a certain approach. Please remember that we have a relatively low amount of data, and this is given by a few thousands of samples which are stored in a hospital's database. And based on that, we want to develop a system which is justifying decision making. And this is quite important because all systems which are working with neural networks are not open to transparency, so we need some aspects and some approaches to change that. So in the first step, this means that we ignore first of all the domain of the skin lesions, but start to develop a reliable network which is able to classify images in general. And in the second step, I show you in detail what this means. We developed a classifier which is able to understand the various visual concepts which might be present in those images. And only in the last step, because we have this lower number of samples, we adapt the system to the skin lesions themselves. At the end, the system should also tell us why the decision-making happens. So we started to use ImageNet in order to train a system which is reliable enough. So we have 13 million of images with 22,000 classes, and something happens like here, so that you have an input image and you have a specific result from the classification. But please see that there's nothing happening with the lesion concepts yet, but we take this pre-trained classifier and used it also to consider another data set which we found, which is from the textile domain. And in this data set, we have pictures of jackets, of shirts, of trousers, of many different things which capture patterns that are visually obvious for us. And as soon as if we input this, of course, the system is irritated and gives us an answer what it is trained to. So, but in such a setting, we make use of a characteristic of deep neural networks, namely that if we train it, we can see that close to the input layer, we have more elementary characteristics or features which are learned, like edges and corners of images. And the closer you go to the output, the more complex or composed are the features. At the end, you have maybe entire images or close to faces. And so we make use of this feature and these characteristics, and then take the entire network and apply something like concept vectors. So we tap the network at the various layers where we have the features in order to build separate classifiers for the visual features like dotted or striped. So we have on one hand side a total overall classification, but also the classification of the visual concepts. And then we do a kind of transfer learning with the last layers to adapt it to the lesion domain. And based on that, we can have an interface that is then able to take input images on one hand side, and on the other side show us the presence of the various visual concepts in here. Also the classification, I think this is a melanoma classification, and then we can use this output also for generative technologies to give it as input to a large language model to produce a text explanation of the system itself. We can also then click on one of those characteristics here to get a heat map to see where these visual concepts are present. So we have a kind of interpretability and explainability dimension of the system, which is important also to be used in general and in specific to generative models. Thank you very much.
Thank you very much, Andreas. Florence, we are really looking forward to your presentation now.
Thank you very much. First, let me thank the organizers for the invitation and for the nice event. It gives me the opportunity to talk and discuss with you some contribution that we have done at Telecom Paris. So just let me just check this. So you should always check things before. Okay, so just briefly, I'm coming from Telecom Paris. Maybe some of you don't know this engineering school. It's one of the 6 engineering schools gathered around École Polytechnique to make this new Institute of Science and Technology called Institut Polytechnique de Paris. And by the way, the French ambassador was talking about the AI summit that takes place, the AI Action Summit that takes place in Paris in February, and there will be a joint event in IP Paris scientific event on the 7th of sorry, I have always a difficulty. Sorry for that. Okay, so here is the place where we are, and what I want to tell you today is that our department, our lab is working on AI and covering all this field of application. And today I will focus on the generative AI. So I'm going to give you an overview, a short overview, based on a snapshot of what we have done, which is linked not only to generative AI, but some elements that contribute to increase the trust and the transparency of generative AI. So we are on the same page about generative AI. So basically, you have to think about deep learning models that generate high quality content. You can think about text, image, but you can also think about audio, tabular data, and even other contents like materials, molecules. And the idea is that, of course, these systems are based on the data they were trained on. So now, if we all acknowledge the spectacular capabilities of generative AI, whether it be large language model or other generative AI such as diffusion model or flow-based models, or maybe the ancestor, which is not that old, but generative adversarial network, we know that, yes, there are indeed spectacular capabilities. You can take any size, nearly any type input of output. You can generate high quality contents. You can adapt after pre-training, as it was shown before, by a post-training. You have this nice capability of zero-shot training, meaning that you can solve a new task using a system that was not trained for this task. And finally, with prompt learning, with instruction fine-tuning, you can nearly conceive a tool that is any purpose task solving. But this comes with some limitations and concerns. We saw a lot of them a few hours ago. The first one maybe is the frugality issue. So these models are greedy in data, in compute time, in parameters. And this is not only a question of frugality, it is also a question of reproducibility and transparency. It makes very difficult for people to reproduce the learning process of some generative AIs when you do not have access to the data, to the annotation of the data, or even to the architecture. And when you have the architecture, if you have not the weight, you are also in trouble. But anyway, there is a lot of ways to overcome this by developing an open source model. However, there's still intellectual property debate. I won't go into this question, but this is something that we have to take into account. And finally, I will focus on trustworthiness. So, of course, for trustworthiness, if you talk about it, you think about bias, of course. So the bias of the data will be reflected in your own system and in the production of the content that you will get. But it can also, by different ways, or the algorithm, the training algorithm is functioning, it can also bring on the table inductive bias, so some bias that maybe are going to homogenize the outputs. I mean, you can have this kind of behavior. You have hallucination and deepfakes, and this is something that you have all observed. And indeed, there is a lack of explainability. I will talk about that in a few minutes, but I want to insist on the fact that one of the big problems of deep learning, and maybe especially generative AI, is that it lacks a confidence measure. So, contrary, we were talking about that, but the field of finance, contrary to finance, for instance, you don't have confidence measure on your output, on the elements of the outputs, and that's a problem. So we are not at the stage to accept that a system could abstain, which is really important. In some cases, it would be better to abstain than to give a wrong answer. And also, I want to insist about on evaluation metrics. So we have a technology that is already used, but we don't know yet how to assess the quality of this technology. So it's a huge problem, and we have, especially as academics, but I think it's a problem for everyone, we have to define evaluation metrics, because evaluation metrics is a key to assess the quality of the systems, to know where they are good, where they are not good, and finally, evaluation metrics is the source of loss function, and the loss function is a way to train, by design, a system that satisfies some property. Of course, it has been also discussed previously, there is a huge danger of misuse. I won't tackle this issue, but I will talk very briefly about the decline of diversity, the problem of data quality, because generative AI is disruptive in many senses, and especially contrary to data science, where we have data, we observe them, and we model the world, generative AI gives us the possibility to produce the data, and we, as it was said by Judith, we have not the ability to distinguish very often between fake data and data. So, coming into detail, so in generative AI, we do all these topics at Telecompare, but what I want to tell you here is that the way we are working. So we are working in a working group which is interdisciplinary and multidisciplinary called Operational AI Ethics. And the idea is that we gather, computer scientists and mathematicians, we gather with experts in law, in economics, in sociology, in ethics, and we try to list the requirements that we'd like to have as property in our system, very much linked with the AI Act, and we try to define together, to design technical solution, operational solution. And so I wanted to also highlight one of the examples that is close to that. It's a system called the AI game. It's a serious game developed by Thomas Le Goff, and it's a way for our students to learn about the European Act. So I want to introduce 3 elements, 3 ways to move forward and to provide one contribution to increase trustworthiness and transparency in generative AI. I will just took 3 examples. The first is disentanglement, edition, interpretation in latent layers of deep architecture. So the idea is the following. To have transparency, to have explainability, what you are going to do, you are going to focus on your system. Here it's a classic vision or audio recognition system, and you want to decipher the information encoded in the hidden layers by building a dictionary of what we call attribute function, which are high level. You can consider it as trying to explain, to distill the knowledge of the complex model into a simpler one, based on functions that are limited in terms of number, but which are successful to mimic the decision. At the end of the process, you can forget about the first network and just use the second network if the trade-off between accuracy and explainability is satisfying for you. And currently, we achieve this on a simple task like recognition in vision, in audio. You can do that. What I want to show you now is the same kind of idea, but with the help of generative AI. So what we do, not only we learn a set of functions that explain the hidden layers, but also we project them into the latent space of a generative AI, so that at the end, after learning, when at testing time, you want to interpret the decision of a model, here a recognition system, for instance, trying to define the species of this bird, what you are going to do, using your generative AI, you're going to be able to edit the image with or without the function that you have learned. So this is interesting because it allows to capture the information by this way. And finally, what did a former PhD student of mine is to extend this idea of dictionary learning for concept extraction in trying to explain multimodal large language models. The second element I want to talk to you briefly, okay, I will skip this example. It's same thing, but molecule prediction, graph prediction, based on transformer. The second element I want to push here is the use of prior knowledge to guide generation. So it's good to be able to generate content. It's better to be able to satisfy some property. Of course, the idea is later to have certificates to say, okay, this data that I will generate will have this property, and to give confidence on that. But just let me give you two ideas. You want to do symbolic music generation, okay? If you do that classically with a transformer, well, it's not very good. There is these inconsistencies in melody and rhythm. So what you can do is to build what we call a structured informed positional encoding that by design introduce the information that has been extracted on the data itself of tempo, phrase, chord, pitch, and so that by design the system is informed about the fact that the content is music, and in music you are interested in that information. So it is also built from experience and machine learning about music recognition and generation in previous years. Another example is classifier guidance, or in some case, classifier-free guidance. This is a nice work. By the way, it's a collaboration with Meta Paris. And the idea is the following. You have a diffusion system. And what you do, you have a sentence, and you go from text to image, and you generate an image. So the system is already on the table. It's available. It's off the shelves. And what you want to do, you want to have a better conditioning. And the way you do that is that you provide a semantic segmentation. So semantic segmentation is say, okay, in this sentence, some of the object will be located in this area of the image. So you kind of control the way you want to generate the image given the text. Okay, so you give more information. But what is tricky and interesting here is that you only change things at inference. At the inference process, at inference time, by changing the way you denoise and you produce data by incorporating a guidance that, in fact, try to align your attention map and your segmentation which is given. It's just an example. It could be other properties, in fact, but the thing is, the model is on the table. It's able to improve for your own task by using some specific information that you want to see or you want to impose. If I have time, but I'm looking at Anton. Third element, it's more on a text large language models. The idea is if we do not know how to evaluate those models, we won't be able to design them properly with respect to the values and properties that we want. So some people in our lab are developing benchmark and metrics. For instance, in the group of Chloé Clavel and Fabienne Suchanek, what they do, they define evaluation metrics for fallacy detection and classification, and they also build collectively benchmark data to test these properties. A very interesting thing, maybe you know that when ChatGPT appeared, I mean, ChatGPT 3, people in some countries wanted to fill automatically their tax form, okay? And the question was, okay, can I use LLM to perform statutory reasoning? And there are people who are working around that, for instance, Niels Olsenberger. And the idea is that first, to test this ability of LLM to do reasoning, you have, okay, so I'm finishing. You can build benchmark for measuring this ability to do legal reasoning. You can also define metrics that are fine-grained in the sense that you are going to check if the error or the gaps between the truths are neutral for your questions or are absolutely deep information that you absolutely not have to use. And interestingly, this brought this team to look at how to factorize LLMs by linking them to knowledge bases and to check the answers in some way, because in law, like in science, we have knowledge base of facts which are verified. I'm going to stop here. I will answer questions if I have the opportunity. Thank you very much for your kind attention.
Thank you very much, Florence. As a lawyer, I'm of course very glad to hear that there is also statutory reasoning in AI. So next, we are looking forward to the presentation by Yasuhiro Katagiri. Yasu, the floor is yours.
Okay, thank you for coming. I'm Yasu Katagiri from Artificial Intelligence Research Center of AIST Japan. My aim in this talk is to somehow propose a kind of different framework, a different frame to think about transparency of AI or generative AI or foundation models, and which I call building common ground or common grounding. And that facilitates mutual understanding between humans and AIs. But let me begin some kind of obligatory introduction of where I work. AIST, National Institute of Advanced Science, Advanced Industrial Science and Technology, is a government research institute, kind of one of three large institutes in working heavily in AI. And I am located in Tokyo, specifically Odaiba. And after the appearance of advent of ChatGPT, generative AI, the scenery of AI research greatly shifted. And right now we are working on developing what we call real-world foundation models, in contrast to mostly cyber-world foundation models that big tech companies are developing. And the idea is to make it multimodal, not only LLM, but also other modalities, developing other modalities of foundation models. And one way is to, since we are still thinking about general LLM, and try to use this to apply for different domains by transfer learning or post-training. So those two-step mechanism is one way to go, we're trying to go. And another way to go is to just multimodal integration and eventually try to make control robot by, based on these technologies. And let me begin with my interaction with LLM, my personal interaction. When I had a chance to go make a trip to Taiwan last year, maybe, and I just asked ChatGPT for travel plan advice. And this is a kind of interactions. So request for travel plan suggestions, and LLM responds with a regional plan, but that trip was right after there was a major big earthquake in East Taiwan. So I asked about the specific earthquake, but the LLM didn't understand I was talking about specific earthquake, so it gives me some general description of earthquake situation in Taiwan and provide me general and to me irrelevant information about how to cope with earthquake in Taiwan travel. So I repeated the request for the same earthquake that occurred in this is the place that the actual earthquake happened, but it also didn't get this earthquake, and also started blurbing out lots of information which is completely irrelevant to me. And I repeated again the request, and eventually LLM gave up, saying that it didn't have the relevant information. So if you think about current LLM as a partner, so LLM is highly knowledgeable and give us potentially useful information. But one-way push, but it's a one-way push of abundant, but in my case, supposedly helpful but irrelevant. And users burden to make sense of voluminous LLM output, even though it may be irrelevant. So users need skills to provide appropriate queries or prompts. Those are the current situations. And the example shows LLM gives very uncooperative. And to me, honestly, it gave me the very patronizing impression of a ChatGPT to me. And it doesn't care about building and utilizing what is called common ground. And if you turn to human conversation, human-human conversation, this is an example of misidentification. This kind of things quite often happens. These two people talk about some people named Sato-san, and there was a misunderstanding who A is talking about by quoting Sato-san. And after some interactions, some exchange, misidentification was identified and correctly. And this is the kind of everyday situation, everyday exchange between humans. And that shows that our interaction, human-human interaction presupposes common ground. And this common ground, I would say, is based on this higher order cooperation. And that means both parties are both responsible for maintaining grounding status. That means they are referring to the same person. Try to guarantee that they are referring to the same person. And if they found, which is not the case, they try to correct or to repair the interaction. And if you compare this kind of human-human interaction, this higher cooperation is very essential. And also think about ordinary human-human collaborations. They shared commitment for task completion. They agreed upon what kind of task they are together working on, which means they form a shared goal between human participants. And how to achieve this goal, that's a breakdown of plans, how to achieve the goal and how to allocate subtasks or sub-goals achievement among participants. And also during the execution, they try to coordinate the execution steps. And those are the kind of ways we humans collaborate with each other. And that involves constant negotiation of what the shared goals should be and how this plan breakdown and task allocation should be, and also coordination requires lots of constant negotiations. And those alignment at the information and intention level is very essential. And this is quite different from what I showed you between two human and current ChatGPT, current LLM interaction. And I would turn to one example. I want to turn to one example that shows or try to accomplish the kind of collaboration between a human and AI. And that's in the medical domain, that's almost similar Professor Andreas example. We call judgment reason dictionary for medical image diagnosis. And the idea is medical image diagnosis usually works like this. Expert tries to provide annotation for lots of medical images, and that's the annotation, and that becomes training data set and trained to construct AI systems. And AI systems provide diagnosis for individual, particular instances of image to be diagnosed. The idea is to, okay, that's the kind of thing. And idea is to construct what we call judgment reason dictionary that mediate this process, and that makes it possible to share knowledge that is involved in this diagnosis. And the idea is to the standard way is to make a data set and train the AI system, and AI system do the diagnosis, but also is supposed to make a diagnosis, but also visualize the kind of images that are involved in this diagnostic systems. And human expert pathologists provide feedback to diagnostic categorization for these examples, and that makes the dictionary, and that's the basic idea. So the expert pathologists sort or classify what kind of information is involved in diagnostic situation, and that is also acquired within this AI training. To be more concrete, this particular instance, the AI first does the self-supervised learning without regard to the particular diagnostic labels, and just make a cluster based on image characteristics, and expert pathologists do the categorization of these clusters. Maybe this image corresponds to this particular diagnosis or the symptoms, and some of the clusters may be irrelevant. And based on this classification, the system try to learn again, transfer learning. And in this case, this is supervised learning. So these are the final diagnostic labels. And based on this output, the system finally becomes a diagnostic AI. And okay. And these are the kinds of dictionary entries. Oh, I'm sorry. Kind of dictionary entries that are categorized after the categorization by pathologists. Those are the kind of one category, one set of pictures belonging to a category, and red region shows these regions are actually deemed as cancerous. And second is also the same. And these are the kind of pictures that are included in non-cancerous, not non-cancerous. People, experts deem this non-cancerous, and system categorizes or grouped these pictures, and those contribute to the negative diagnosis. And I will probably do not go into the detail, but the entire purpose is to give a diagnosis to the entire pictures. But these pictures are cut up in smaller patches, and based on the feature extractor trained network, these gives each patches are turned into a kind of feature space, embedding space, and those spaces, those vectors are summed up based on this inference estimator and provide final feature vectors, and that is also fed into final classifiers. And that's the idea. And the point of the system is the system outputs not only the diagnostic yes/no answers, but gives the highly significant area, in this case, maybe this region, and shows the corresponding related dictionary item like these. And these are actually correspond to a malignant region. So this provides not only the final diagnostic result, but provide justification or reason for why the system provides certain diagnostic results. So that make it possible for doctors to think about how to weigh the result that is provided by the doctors. And that I think corresponds to the establishment of common ground between human, in this case, doctors and AI systems. So I would argue this building and maintaining common ground is essential for the transparent AI. And in this case, medical image diagnosis, and also in the previous one, my conversation with GPT, I will greatly be facilitated by common grounding to disclose their reasoning and preferences and try to align their behaviors toward their shared goals. And as I said, common ground presupposes higher order cooperation, and probably common grounding AI will also be essential for establishing trust in AI. Okay, thank you.
Thank you very much, Yasu. This was a truly fascinating presentation. So first of all, I'd like to thank all of the speakers once more for their insightful presentations on very different aspects of transparency, actually. And so I think what the presentations have shown us is that transparency is really an issue in all fields where we can apply artificial intelligence. And it also showed us that in many fields there are actually approaches that try to make AI more explainable, more interpretable, and therefore more understandable to humans. So if I may start with Andreas, who showed us some of his work on the application of AI in the field of medicine and diagnosis. So one question that came to my mind was one that you actually mentioned in passing, which is biases. So as I'm sure most of you are aware, there are huge biases when it comes to medicine, especially when it comes to data that we have. So there is a data gap when it comes to gender, there is a data gap when it comes to ethnicity. And I was just wondering, how does that play into your work? Because when we are talking about explainability and you would make AI lay bare certain criteria it is basing its decisions on, would that help with mitigating biases, or what's your perspective on that?
It's a very good question. I think if we look at the data, transparency starts with the data. since the data might be incomplete, inconsistent, maybe unbalanced from the samples you used. And therefore, it's quite hard to get a view whether a AI system is making decision objectively. This is a really hard problem, since we as a human being, we are subjective intelligences, so to say, so that we have always a very different perspective of problems and therefore make different decisions. And we are reflecting this or mirroring this on AI systems, which makes it hard. But anyway, recently we started to investigate more deeply the various functions of trustworthiness, including transparency on one hand side, but we also discussed about functionality. Is the system functioning in the right way? Is it robust enough? Or is it safe and secure? Does it respect to ethical conditions, etc.? So we are trying to start with the data to provide a kind of set of data sets that could be used to test the various criteria in a kind of standardized way to establish a process which at the end could provide a kind of certificate for AI system. This is based on a national initiative, and it's not DFKI itself who give the certificate, but we have partners like TÜV, a well-known German brand, or PricewaterhouseCoopers is involved, DECA, VDI, and others. And we are the researchers. And it's a lot of work. We just start with the medical domain, and then there are many more domains, financial, crime investigation, high-risk areas, where all these questions raise. And the data also have this privacy issue. So also what data could be used, to what degree. So it's a still unsolved question.
Right, but I think your answer did shed some light on this yet unsolved question. So if we're moving on to Florence, thank you for this overview over different research that is going on at your institute. It really showed a huge bandwidth of research. And so I was wondering, since, because you were so kind to stick to the time limit, you had to skip one of your slides on, actually, I think it was about structure generation, right? So I was just generally wondering, what will be the future projects you are working on at this point?
Oh, thank you very much for the questions. Yes. So currently we are developing a new research project about science discovery. So how to use generative AI and other AI techniques, especially to do molecular elucidation, material design, or discovery of or drug discovery. And the idea is to combine different capabilities of generative AI. For instance, using generative AI to explore large, huge combinatorial spaces of structured data, like molecules. It is something that is already used in recent works. But also the idea is that large language LLMs can give us the possibility to interact with the huge amount of data and the information contained in papers, in scientific papers, and we could imagine to customize LLMs on some scientific expertise. But this does come with some security check, sanity check, so we will relate and really check the information provided or the suggestion provided by LLMs by knowledge bases. So the idea is that currently in science discovery, you have reinforcement learning, basically technique behind AlphaGo. You have this generative AI used to explore a large set of unknown data, if I can say, by sampling, by generating them. But now I think with LLMs, there is this other component of having a kind of assistant, scientific assistant, that can come into the loop. But if we want to check the boxes that we have listed just before, we need to do fact-checking, scientific fact-checking. It's mandatory.
Perfect. Thank you very much. That sounds really interesting. So finally, to get to Yasu's presentation, which I found really fascinating, what I really liked is that you put an emphasis on who actually is responsible of common ground in relationships with artificial intelligence. Because I think most of us, at least myself, I've been in the position you've been in when you were talking to ChatGPT, and at some point I felt like it was my mistake. So I felt that I didn't give a good enough prompt. And so you saying that we should actually focus on who should actually bear the responsibility to lay common ground in human AI relationships, I found that really, really fascinating. And so when you also got into the example of diagnosis using AI, we've heard from both Andreas and you that there is a certain scarcity of data. And so one thing that you at some point brought up was the idea of synthetic data. So would you mind to elaborate on the meaning of this concept for your work a bit?
This particular study I talked about, I don't think they use synthetic data yet, but during the construction of vision foundation models, actually one of our selling point is the foundation model can be built by using solely synthetic data, mathematically generated data, and by combining this synthetic foundation model trained by synthetic data and transfer learning by real-world images. That's one promising way to expand the possibility of application of visual foundation models in lots of different image processing applications.
You want something to add? Yeah, sure.
Yeah, this is, I think, a valid approach. I think you could also go a step further. We used real-world images to really generate synthetic data on low contrast microscopy of multi-cell cultures, meaning that we also have a limited amount of data, mostly from monocultures, and we did segmentation of the cells, including also a noise categorization, and then we mixed up the pictures to synthetic pictures of multicultures, which were surprisingly good to be used in real practical cases. So it's a mix between reality and generative approaches.
Thank you very much for both of your answers, actually. That was really insightful. So one area where, when it comes to AI and decision support systems in particular, explainability is an issue at present as well as military applications of artificial intelligence. And I'm not going to get into that too much. But one of the issues that comes up there is that we are talking about split-second decisions. And one of the advantages of artificial intelligence is that it can make certain decisions or analyze certain data much faster than humans can. And so is there any way, and this is an open question to all of you, where we can improve explainability of AI decision-making in those situations where we are pressed for time? Does not necessarily need to be a military application, but there are other fields where we need to make a quick decision.
Yeah, it's a difficult question, but okay, when it comes to explainability, people try to build explainable systems that are frugal by design. Okay, so I won't worry too much by the rapidity of the decision, but the problem is the interaction with the human in the loop. So be able to check, to have this double check by human if it comes to military application. So that, I mean, this delay between the answer of the system, let's say it is a simple system that you can analyze really. If you want to put the human in the loop, there is a need to spend at least a few seconds.
This is also difficult to answer, since decision-making strongly is related to the subject, him or herself. Yeah, I think to reduce the very complex dimensions of relevant data for decision-making very much depends on who is looking at the data, what experience the person has, and what risk is related to decision-making. So it's not that easy. There are some experiments which are also related to cognitive state recognition in respect to such decision-making, to see whether people are confident in a certain situation or they have cognitive load, yeah, which sometimes happens and which is influencing their behavior in a certain way. Also, we also found, not in military applications, but we also found people who seemed to be confident, but they were wrong. Yeah. So this is also something of a very personal attitude. And so therefore, it very much depends on the situation and the application and the time left.
I agree it's a very difficult question, but when you go into real-world foundation models and real-world application like robotics, it's kind of inevitable to delegate decision-making capabilities or agencies to AIs, partly at least. And autonomous driving is one typical example. So people are getting used to the existence of autonomously driven cars. And that's one issue is social responsibility, social acceptance. It started out that there shouldn't be one incident, one accident when automobile is driven by AI. But these days it's switching to the new conception of if it's better than human driving, it can be acceptable. That's the change, not in the technology, but or technology is improving, but basically the change is in social acceptance, social acceptance level. But also there's a kind of joke, if it's the stake is very low, kind of buying something cheap in Amazon, that people shouldn't care that much. But what happens if the AI decided to order the same thing a million times? So that becomes suddenly very significant. So it's that shows the difficulty. I think difficulty of the problem. But the topic I raised is just to cope with this problem. One way to think about is something like AI and human become somehow co-equal in terms of what kind of decision to proceed to the action.
Thank you very much. I think those were all very helpful answers to an admittedly very difficult question. So one question I have in particular for Andreas and for Yasu. When we are talking about applications of AI in the field of medicine, how does that change the doctor-patient relationship in the long run? Because at this point, we are mostly used to doctors being experts that are facing the patient. Will the role of doctors be more one of like communicators that communicate AI-generated results to the patients to give them a human face? Or how will this relationship change in the future with the use of AI?
I think medical treatment changed a lot. There are much more insights, there are much more specialized medications, so the task of medical doctors got more difficult, more complex, and if you see also the economic pressure that doctors usually have a limited time for each patient, you can cry for support. So meaning that for example, taking this dermatological world, where people are affected by skin lesions and usually don't go regularly to the doctors. And it might be helpful maybe to have a possibility of home screening, where you might have a special agreement with your health insurance that you do regular screening, and the AI helps you to not forget anything, and only the suspected changes or the lesions could be reported to the doctor, who gets the second opinion, to have a better way of treating and also to react to the patients in a certain way. So I think, yes, this socio-technical constellation will become more frequent and more practice, and therefore there will of course be a change, as in almost every domain where we use AI.
Thank
you. I think I should mention a different aspect of the judgment religion dictionary. Andreas briefly mentioned the disagreement among experts. So medical diagnosis, there can be disagreement on what kind of diagnosis expert provides. And that dictionary gives some sort of media for doctors to compare with other doctors, other experts' decisions or evaluations, so that hopefully contributes to better outcome and also better expertise among experts, and that I think shows that this AI technology. Potential of the use of AI technologies for education for medical students, and so that's a kind of new way of applying the technologies. And also, it can also be used, since you mentioned doctor-patient relationships. I think doctors can also use that kind of technology to provide information, useful information to patients, not only the result, but also why the system, which is ultimately based on expert collection of expert decisions. So that will provide some persuasive, I would hope, a persuasive way to provide evidence for certain diagnosis to patients.
Thank you very much. So I have one short question for Florence before we move on to the audience questions. So you were also speaking about statutory reasoning of AI, which of course interests me given that I'm a lawyer. And so one issue that we have been facing is, of course, that of hallucinations, that AI makes up some case that ended up on some lawyer's desk, and then he tried to use it in court and failed miserably because it was discovered. And so you were talking about hallucination detection mechanisms. So could you maybe briefly talk about that? How would that work? How would those hallucination detection mechanisms work?
Yes, so in fact, in the case of statutory reasoning, well, there is a term of reasoning, and currently LLM are not based on automated reasoning, so it's relatively easy with automated demonstration techniques to show that given some fact, given some input, and given some rules that you know from the law expertise, you can check, in fact, with special cases, how the LLM answers. So there is this idea of having legal benchmark on one side, so specific case that LLM should be able to relate to some case and give the answer. But the way it works, because it's based on statistical learning and not at all on reasoning, you can check that from another system which is based on reasoning. And there's something I wanted to highlight. It is currently frequently used. We use LLM to check if some content has been developed or produced by LLM, but this is maybe not exactly the right way to do that. So it's possible that when it's an extra an external system to do this checking.
Perfect. Thank you very much for this insight. And I think now we are ready for questions from the audience.
Thank you very much. And we do have a couple of very good questions already. Let me start with a question on responsibility and accountability. Who would you say, it was phrased in different ways, but who would you say should be held responsible for harmful impacts of AI? There was one pointed comment which I kind of liked. Should system developers and basic researchers, despite their different interests, be equally accountable? Sounds like blaming thermodynamicists on plane crashes.
You should ask the lawyers, maybe, but well, we already had many discussions, I think, in different settings about this. And as I already mentioned before, in a different question, I think it starts with the data. So you can ask those who are developing systems or training models based on the data. They are depending on what is delivered. And so we read about many examples in different domains that the data is a really challenging aspect here. And usually those who use the data are not the expert of the domain. And to really then assess whether the data has a problem or not is quite hard. So are those who produce the data already those who are then responsible if something happens? I can't answer. So we should, I think, wait until those experts in the legal domain have a solution for it.
Yeah, I agree with your answer. This is out of the scope of our competency as a computer scientist or mathematician. So we really need to refer to experts in law.
Well, as you probably are aware, it's a very difficult question for lawyers as well, but I think it's not a particularly new question because, even if you think about gun manufacturers, you can ask pretty much the same question. Are they responsible for killings that are committed with those guns? And interestingly, at least under German law, what we've developed is a certain criterion of social adequacy of what you are doing. So is what you are doing socially accepted? So for example, selling kitchen knives, perfectly accepted socially. And therefore, we do not accept accountability of the person selling the knife or the person producing the knife. And that's a very interesting thing about AI because it's so new. We are still working on those social standards. What do we accept? What kind of development do we accept socially? And so therefore, accountability is still a bit difficult to establish, even though the EU is currently working on a directive on it. So no final answers from the lawyer either, sorry.
Thank you very much. An additional question, maybe of a more technical nature. How can we check and control what's happening in the deep layers of neural networks? Is this even possible? And how do we know how basic knowledge is encoded in RNN and in recurrent neural networks?
Well, what you can do is to, let's say, control how you learn and encode information in your latent layers, hidden layers, by checking if you are able to make some high-level addition. So there are nice experiments that have been done by leveraging simple PCA and exploring different directions for representing the data in a latent space. But I think the key is first to understand to which point the hidden layers that are currently built are able to highlight or encode, for instance, the presence or the absence of an information. And the second key question is, of course, by design, ensure that when you build a neural network and when you are focusing on a specific internal representation, you are aware of what operation could be done. And obviously, what we know is that I mean, this is probabilistic and statistical learning, so we know that nothing will be perfect. There will be areas in the internal space where we won't be able to say a lot, but maybe there is at least some region where we have more confidence.
I think maybe.
Professor Katagiri, perhaps? Do you want to go ahead?
I just agree. I agree with the opinion. And I mean, there's this intermediate layer representations that variously called embedding or feature space or hidden layers. And those corresponds to a kind of compactified representation of input or input-output relationship. So I think that's one way to probe into the internal working of or internal representation of neural networks. And that study I talked about is also the instance of use of this feature space by combining this feature vectors to the originating input. And there probably are other techniques to do some sort of statistical or probabilistic analysis of that feature vectors. And I think, but recently I think Anthropic proposes some sort of what they call mechanistic interpretation that really focuses on what neurons are active when systems are behaving in certain ways. That is, I would say, some sort of brain research analog of neural networks, and I'm not sure that that works out. But I think that lots of people are start working on the analysis of internal working of those big models.
Thank you. Professor Dengel, do you also want to comment?
Yeah, I think it's important what Florence already mentioned during the training phase to measure the impact of the various filters and see on what data they react in a certain way, maybe to cluster them. We made experiments, for example, to only use from a certain cluster the filter which is reacting most, and then even down-tuned the network, getting better results. And while using the network and visualization, you can see small changes during versus sanity checks, for example, what impact this has in the network. So implicitly, you can see somehow how the network reacts on certain data constellations at the input.
Thank you. To maybe squeeze two more questions into the time that we still have available, I try to shorten the first one in the way that there's a question, shouldn't there be regulations that force model providers to release their training data for transparency purposes? Brief show of hands from the panelists, who is in favor? Regulations that require?
Depends on the application.
Yeah.
Okay, yes. And the opposite, against creating such regulation?
Well, it depends on the kinds of data also.
Okay, yeah. Would you maybe go ahead, Professor Katagiri, and comment on that?
I mean, the ImageNet data is very typical. So there's this concern of privacy and intellectual properties these days. So we need to find a way to avoid those concerns. And if it's satisfied, it should be open for everybody. And also, if you go into actual business applications, those people have lots of proprietary information, those companies, and that cannot be shared. So there's a dependence on what kind of data and what kind of application. And basically, if those issues are resolved, those data should be open and shared.
Thank you. Professor Dengel, were you thinking along the same lines, or is there anything? Yeah, okay. Florence, do you also want to comment on that?
No.
Okay, yeah. I think one major issue that we haven't touched upon so much is the issue of copyrighted materials, which of course is very important. Have been backlashes. in the past. I had a very interesting conversation yesterday about the case of Japan, that apparently currently regulations still permit the use of a lot of copyrighted materials, but of course creators are very concerned about that. How do you see this, this conflict play out? Copyrighted materials on the one hand that might be necessary to improve quality of results delivered, but at the same time the issue of compensation of maybe not being able to use certain certain materials.
Yeah, I think this is not so easy to answer again, but I think the most important aspect is the reference. Yeah. So and if you know, we talked about Aleph Alpha, they try to refer to the original data if they use LLMs, and there are a couple of others do the same. But we as scientists, we also do something copyright. We build our own ideas on ideas of colleagues somehow, but refer to their work, hopefully. Yeah, which makes it proper. And the same holds at the end for LLMs. And there are some quite nice new models, not only for text, but also for other domains that are following this.
As a layperson, so is it usually possible to trace back where information comes from? Or is there a big pool of knowledge that is not quite traceable?
If you do a check of a dissertation, it depends on the percentage of overlap, yeah, and this also holds, I think, for any source. How much in this picture regarding, I don't know, whatever is similar to, I have no idea.
Thank you. Any additional comments?
I just want to say that old-fashioned non-parametric models and statistics, which are basically kernel-based or decision tree, are models that keep information about the training data. So if you want to share a decision tree with someone, what you're going to do, you're going to give a list of leaves of the model, and for each leaf you have a set of training data that fall into this leaf. So what I want to say that for some application in a small or medium data regime, it might be the case that you are interested to have a trace of the data that you cannot have when you use, well, what it's difficult to have when you use stochastic gradient approach and parametric models.
Thank you very much. Any additional comments? Okay, we're also approaching the end of our time. So thank you very much. Big round of applause for the panelists and the chair.